implicit differentiation. We will see how can we distinguish the implicit and explicit forms of the functions, and how can we determine the derivatives applying implicit rules of differentiation. So first of all, try to understand about the difference of explicit and implicit functions. In explicit functions, the functions can be expressed by an equation in terms of one variable, which means all the equation will be represented by y on one side and equals to some 3x square minus x plus 2, for example. So y is the dependent variable, whereas the x is the independent variable. You can clearly say that on one side, on the left hand side, the y is written, whereas on the right hand side only one variable, that is x, is written. Means all the terms are expressed in terms of x. Whereas in implicit functions, the functions are implied by an equation, but you cannot separate the variables, which means that the y and the x are written on the same side. So here you can see that on the left hand side the variable x is written, and also the variable y is written, and also a variable y is written. On the right hand side there is a constant, but it can also be a variable, Now this kind of functions written on the right hand side, they are really very difficult to express in terms of x because of different y expressions. Now let's see first of all how to take the derivatives of the implicit differentiation. Before we start solving the question, understand the idea of implicit differentiation. Now let's check out that what we have done previously in the explicit differentiation and how we will find out the derivatives of the implicit functions. So remember that if I ask you to take the derivative of x, previously we said that the derivative of x is 1. Why? Because we are differentiating the x with respect to x, means d by dx of x equals to 1, which means that the derivative of x with respect to x is equals to 1. Now if I ask you to take the derivative of y with respect to x, means all the derivatives take out with respect to x, so it will be written as dy by dx. Or the derivative of y will be y prime, because we are differentiating it with respect to x. Now if I ask you to take the derivative d by dx or prime, anything you can write, the derivative of cx, we know that the derivative of cx with respect to x again is c. But if I ask you to take the derivative of y, cy, with respect to x, so you can say that it is equals to cy prime, or in other words you can say c dy by dx. Okay, so in order to take the derivative of for example 5x, so the derivative of 5x is 5, derivative of 6x, it is 6, derivative of half x, you all know that cx equals to c, so half x equals to half, derivative of square root 2 and x outside, so it is equals to square root of 2. But if I ask you to take the derivative of 5y with respect to x, you will say only 5y prime. Here you can say that y is not equals to 1 because you are differentiating with respect to x. Now half y, so the derivative is equal to half y prime. Or square root of 2y, the derivative with respect to x is root 2 and y prime. So I hope that this picture is clear to you. Now what if we take the derivative of x cube? with respect to x. So we all know that we bring the 3 here and the x, and from the power we subtract 1. So it becomes 3x square. But if I ask you to take the derivative of y to the power 3, so try to manage it with the help of the chain rule of differentiation. So first of all, take 3y square and then again take the derivative of y. So if I ask you to take the derivative of y to the power 4, so you will say that it will be 4y cube and then write down y prime. Similarly, if I ask you to take the derivative of x to the power 4, you all are familiar with this rule, that is 4x cube. Now the next thing is x and y, if they come together, then always apply the product rule of differentiation, which is fg prime plus gf prime. So using the product rule, just keeping in mind that the first function f is x and the second function g will be denoted by y. So fg prime, it means x, y prime plus g, that is y, and x prime. And we all know that x prime is 1, whereas y prime is stay y prime. So the derivative of x prime is 1. So in short, we can write it as xy prime plus y. Similarly, if x over y is written, you will use the quotient rule of differentiation. Now let's start solving the question containing the x and y on the same side of the equation. So using the implicit differentiation, we are ready to take the derivative of 16y square and minus x square equals to 16. So see here, look here, that 16y square, what is the rule? That here use the constant multiple rule. Multiply 2 by 16, it will gives you 32. Y, from the power we minus 1, so our power it stays 1, we don't write the 1. And then write the y prime because the y with respect to x. Minus derivative of x square is 2x equals to derivative of 16 constant equals to 0. Now keep the y prime on one side, which means that this term on one side, and bring the 2x on the other side. So bring the 2x on other side. So we will write here 32y prime and bring the 2x here, there, minus 2x goes there, it gives you 2x. Now you want to solve for y prime. So keep the y prime here, divide both sides by the terms which are written with y prime. That is, divide by 32y and here also 32y. So this would be cancelled and you will get y prime equals to 2 and 32 will gives you 1 over 16 and x over y. Or you can write it as x over 16y is your final answer. Let's see how can we solve such questions. So here y square plus x square minus 4x plus 6y plus 9 equals to 16. So y square gives you 2y and y prime. Always when we have the power rule, we are using the power rule to take the derivative of y. You have to write 2y and again y prime. Plus derivative of x square will be 2x minus derivative of 4x using the formula of cx equals to c gives you the 4 only, plus same cy or 6y, it will gives you 6, but the derivative of y is y prime, not 1. Derivative of 9 is 0, so no need to write the 0, and derivative of 16 is also 0. Now keep the y prime on the left hand side, means 2y y prime plus 6y prime, keep them on the left side and the other terms bring on the other side. So plus 2x goes on the other side of the equality sign. It will gives you negative 2x. Similarly, negative 4 goes on the other side, gives you positive 4. Now from the left hand side, take the y prime common. So you will write y prime only one time and the remaining terms inside the bracket, that is 2y plus 6 equals to negative 2x plus 4, you write as it is. Divide both sides by 2y plus 6. So in the end, or in other words, just bring it down. So we will get 2x plus 4 over 2y plus 6. Another example in which x and y are written together. When then the x and y are written together, we already discussed that we have to apply the product rule, that is f and g, which is fg prime plus gf prime. The first term will be named as f and the second term call it as g. So we can use fg prime, which means f is our x, g prime that is y prime, plus g that is y, and f prime is 1, equals to the derivative of 1 is 0. Now write down here xy prime plus y equals to 0. Keep the y terms on the left hand side and the other terms on the other side. So plus y goes on the other side, gives you negative y. Divide both sides by x to solve for y prime and we will get negative y over x. Let's solve another question. Find the y prime of x4 to the power 4 plus y to the power 4 equals to 16. So the derivative of x to the power 4, bring the 4 in the shoulder, write down the x, from the power we subtract 1, so you will get cube, plus same way bring the 4 in the shoulder, write the y, from the 4 subtract 1, you will get 3, but since it is a y, you have to write down y prime equals to derivative of 16 is 0. Now after this, keep the y prime terms on the same side, means the left hand side, and the remaining terms shift on the other side. So plus 4x cube, when you will bring it to the other side, it will gives you negative 4x cube. Now in order to solve for y prime, divide both sides by 4y cube. So 4y cube and 4y cube cancels. From here 4 and 4 cancel out and your final answer is y prime equals to negative x cube over y cube. So this is our final answer. Here is another question, a little bit complicated. So x cube plus y cube equals to 6xy. So the derivative of x cube, bring the 3 in the shoulder, write down the x, from the power subtract 1. Similarly, here 3y square and again you have to write y prime. Here you have 6xy. So I can take it as 6x as my f and y as my g. So formula is fg prime plus gf prime. Substitute your f as 6x and g prime, that means the y prime, plus g, that is your y, and f prime means the derivative of 6x, which is equals to 6. So I did it directly. Now we have to solve for y prime, means find the derivative, find the d by dx of y. Now bring all the y prime terms on left hand side. So here you have a term 3y square and y prime on the left hand side. But on the right hand side there is 6xy prime. So bring it on the left hand side, plus 6xy prime will go on the other side. It will gives you negative 6xy prime equals to. Now here on the right hand side already the 6y is present. You have to bring or shift 3x square on other side. So you will get minus 3x square. Now take the y prime common as you are solving for the y prime. So we will write y prime, and in the bracket the leftovers, that is 3y square from the first term. Then there is a negative term here, and then from 6x from the second term, equals to 6y minus 3x square. Divide both sides by 3y square minus 6x, and here also 3y square minus 6x. Now here you can leave it over here, but I would suggest if you take the 3 also common. So if you take the 3 also common, you will get here 2y minus x square, and in the denominator also take the 3 common, you will get y square minus 6 as a 6x, okay, as the common factor. Now why we did this? Because in order to simplify and 3 cancel, so final answer of is y prime equals to 2y minus x square divided by y square minus 6x. Here another example, x square y. So here you can see x square y, they are multiplying with each other. So here you will use the product rule, that is fg. So you will use fg prime plus gf prime. Your f is x square, which means your derivative is 2x. Your g is y, which means your derivative is y prime. Put it in the formula. Okay, so here you have f, then you have g prime, that means y prime, plus g, that is y, and f prime, that is 2x, equals plus now the derivative of 2y cube. So it will gives you 3 times 2, 6y from the power, subtract 1 square you will get, equals to derivative of 3x is 3 plus derivative of 2y is 2y prime. Now here y2x is not appropriate way to write, so always write the number, then x and then the y. 6y square equals to 3 plus 2y prime. Now as we know that we are solving for y prime, so keep all the y primes on the left hand side. So I will write x square y prime, which is already present on the left hand side. Bring this 2y prime on the other side. You will get negative 2y prime. Now equal sign and all the other terms on the other side. So it will be 3 on the right hand side already. Now bring the 2xy on the other side. You will get minus 2xy. Bring the 6y square on the other side. It will also give you minus 6y square. Now take the y prime common from here. You will get, after taking the y prime common, you will be left with x square minus 2. And on the right hand side, no common, so 3 minus 2xy minus 6y square. Now to find the value of y prime, we will divide x square minus 2 both sides, and to honor the time, we will not write the x square minus 2 on both sides, just directly divide it and write the final answer.